Hello. Welcome everyone back to the Keys to AWS Optimization. We are here to learn even more about GenAI. We did a whole episode last week about optimizing Bedrock, but we thought we know everyone wants to learn even more. And so we're going to be asking some experts today, your questions, my questions, John's questions about GenAI. And we have Aaron Brown, who is in the same department as us, which is exciting, to talk about some high-level strategy when it comes to GenAI, the different dimensions, when it comes to cost and elements that you can pull to make sure that you strategize a bit better when deploying your GenAI. And then we're going to bring on Omri, and he's going to talk a little bit more about GPU focus and some observability. So stick around till the end of the episode for that. But welcome, guys. Let's start off with our normal fun question, which is, have you had a frugal week or a splurgy week? John, why don't you kick us off?
Yeah, thanks, Steph. Well, I guess a little I'm getting tongue-tied already. A little splurgy because we've got Mother's Day coming up this weekend. So I hope everyone who's got a mother in their life is maybe getting a little splurgy, getting ready for, taking good care of those folks that we've got in our lives that are our mothers.
Oh, nice. It's a different date in the UK as it is to America.
Oh, is it really?
Every time this happens, yeah. Ours was like March. We already did it.
Hey, take good care of them anyways, right? If you got a mother, still do something nice for them, whatever.
I always panic. I'm just like, oh my God, is it now? And then I'm like, oh no, it's not. But Father's Day is soon as well. So anyway, it's a whole other thing. But Aaron, what about you?
Yeah, I think this week, so I'm typically based out of Chicago, but this week I'm traveling in Gothenburg, Sweden, and I got to experience a couple of really fun, nice restaurants here in the evening after some work events. And it's been really awesome kind of experiencing some new culture, some new food, and just experiencing the new scene here. So I think it's a little bit more different than the typical at home.
Yeah, it's always fun. There's balance with traveling for work where you get to experience all this stuff, and then but sometimes I feel like I've done many a trip where I'm just stuck in an office all day. So as long as you kind of like plan for that. Speaking of work trips, as a reminder, I will be at FinOps X in San Diego. It's coming up soon, so make sure if you've got your tickets already, please do. And if you look in that agenda, you will see mine and Adam, who was on last week, talking more about GenAI. I know. Don't worry, you're not going to get sick of us, I swear. Talking about some levers about using the same playbook that you all already know and doing that for GenAI, as well as a session with Justin Marks, who's been on before, about SQL querying, the stuff that we love to do day to day in terms of cost. But we have a jam-packed episode today, so let's get into it. So welcome everyone to the Keys to AWS Optimization, the show we share stories, concepts, and solutions to help you unlock your spend at AWS. My name is Steph Gooch. I'm a senior SA advocate in the customer acceleration team, doing the broad one. And my job is to help you get on board with all the FinOps questions you have and learn and share information. John?
Yep, John Massey, and I'm a principal optimization solutions architect on the Optics team. So working to help our customers, work backwards from any of their cost efficiency goals, both GenAI related, as well as, all their other workloads and FinOps type stuff.
Brilliant. Yeah. And Aaron, let's hear your 1-minute origin story.
Awesome. Hey everyone, Aaron Brown. Background on me is spent early part of career in the U.S. Army doing cybersecurity and software development effectively.
Oh wow!
A mixture between active duty and reserves. Did that for a bit, and then on the civilian side, started at Accenture in a data science group. Worked through that career path. And then for the last 3 years before coming to AWS, spent a role at a company called C3 AI, doing product development for building search systems and for different applications out there for different customers, mostly in the public sector. So that's a little about me. And at AWS here today, I'm a senior solutions architect that specializes in GenAI, part of our customer acceleration team that focuses on helping customers accelerate their journey and unblock technical issues when it relates to model training, deployment, building agents, and using tools, whether it's open source or some of our managed services tools on AWS.
Brilliant. And I'm excited we've chatted a lot when I was getting ready for my summit talk. Aaron was kindly helping me learn a lot about stuff I didn't know about, and we're going to do the same today when it relates to FinOps. Before we do, let's do a quick poll. So I want to see who we have watching today. These guys have seen this kind of stuff before. If my share screen will work. And this is always classic. You're just like, oh, I'm ready. Oh, I'm not. All right, let's see. So if you're not familiar, if you put 1 in the chat for yes, 2 in the chat for no, 3 for basically I live here. So have you watched us before? Please let us know. You can do this on the chatter as we go. And throughout the episode, make sure that you drop any questions, comments in the box. We will try our best to answer them as much as possible or bring up your thoughts. And if you're watching us after, you can always put any comments in the YouTube video and we will check out there. So a mixed bag. Got some people who are relatively new to the show, some who have been here all the time, which is amazing. Okay, thanks everybody. Let's get into the actual topic at hand. So Aaron, I feel like a lot of people, especially the learning curve I've been on at the moment, generalize and kind of dumb down maybe a bit of GenAI. But for today's topic, when we refer to GenAI, what is in this conversation? What elements are we talking about?
Definitely. Well, at a very high level, first start off with the use case. So I always like to tell folks to first work backwards from the business problem or probably consumer problem you're trying to solve, and then back into the actual technology. So making sure first that we have a clearly defined problem statement, machine learning objective, we have data, and ultimately that this is a problem worth solving. So doing that use case scoping and validation up front, that sometimes we, a lot of organizations, actually big and small, will skip on, really is critical to then defining really, is this a Gen AI problem? Or is this really traditional AI and machine learning? Or is this a regression problem, time series, etc.? Once we kind of do proper use case scoping to identify if this isn't really a problem, or we need to do either text prediction, code generation, generating images or videos, then we can work into actually further scoping out what are the right dimensions for actual implementation. And at a very high level, and we'll go into this I know more in the talk session, but it really comes across really your model selection, which is influenced predominantly on the use case requirements that you do in that scoping process based on really the cost budget you're allocating, the accuracy that's acceptable for the business, and latency. It's effectively that three-legged stool that you need to optimize for as a classic optimization problem where you have a ton of constraints and then we have an objective function and we effectively optimize to define what is the right parameter output. And then I'll say the other really important component, and we'll dive more into that, is having that clear cost governance framework where you can actually have the ability to see your cost visibility. So you can know, for instance, the tokens that you're outputting, that you know the requests per minute that are being done, no matter whether your inference engine is a managed service solution like Bedrock, or whether you're using a self-managed open source. You need to have visibility so you can implement tagging, just like we would with any other workload, so that we can enforce cost controls and measures and ultimately optimize for that. So I know it's a lot to unpack, but maybe that's a summary.
Yeah.
Perfect.
Yeah, there's a lot that you said as well, which is not that alien to the stuff that we work, the kind of finance practitioners watching today will know. And it's kind of like we used to say that when we were deploying in the cloud when I was a customer, was like, what are you trying to build? And then we used to choose the right tooling. So the same conversation is people having with, does it need to be serverless? Does it need to be a container? Does it need to be like an EC2? This is the same challenge. It's just different words in the background, I feel like.
I think completely agree. If it's one thing I think folks should really take away, it's that, Gen AI, while it has a big name and it's in the news, it's trending on LinkedIn and everyone's looking for their just talk about it. It's really not too different from a cost optimization perspective. There's new constraints, but there's new constraints in every use case, in every implementation. But the core methodology remains the same.
Yeah. And we have a question I want to bring up, which is, what do you think the biggest challenge for GenAI cost optimization will be in the next 2 to 3 years?
Yeah, I think it's about predicting that future load. So forecasting right now, a lot of folks were saying last year was the year of production or even this year. I think still right now, we're still dealing with a lot of what we call workflow systems or simple workflows, effectively your traditional retrieval augmented generation, effectively chatbot application. And while those are really powerful and useful, there's a lot of talk right now of agentic AI and more advanced workflows. And while those are coming, they really haven't hit full production yet. And with those new truly agentic systems, the amount of tokens per minute and requests per minutes increase. And since they are more quote unquote autonomous. We can dive more into what that really means, but just know that effectively there was more back and forth, there's more communications And with that means more cost. Now you can execute more on the business side, more value because you're doing more capability, but at the same point, then you'll have more cost. So as a business, we'll need to have better controls to actually forecast out that future demand, just like how we have to do today for our traditional applications. But again, the methodology is the same. It's just going to become more and more of a problem as these systems become more and more quote unquote autonomous and have more freedom and flexibility to complete these objectives.
And with the words of token and stuff like that, people are like, I still haven't dived into these. Last week we really covered in detail. So check out last week's episode for that. Sorry, John, were you going to say something?
Well, I'm curious, Aaron. So, folks that maybe were, building out more like workflow centric AI workloads, building net new greenfield workloads in that model last year, maybe folks that are approaching things a little bit differently this year with things that could be more agentic. Are there any like kind of common pitfalls you think people should be aware of for either of those cases as they start to kind of move from the prototyping stage to kind of making this thing a little bit more real and scaling up? And don't want to get ahead of ourselves here too. If we're moving.
No, that's good. That's good.
But no, I think that's a great question. I think again, fundamentally, don't follow the hype. That's my biggest thing up front. Don't follow LinkedIn, MCP, A2A. Bottom line, there's still draft RFCs for security, and a lot of these aren't in full scale production yet. That will come eventually.
So many of those words I don't understand, but I'm now no, I won't follow the hype on that. Yeah.
But if it's one thing I want to take away, it's again the importance is scoping the use case up front, so that ultimately then the technical solution and the AI algorithms that you use to actually implement. So I think back to your point on like where we're going with this, I think making sure we start first, not with going truly to maybe full agentic application if we don't even have it, if we can't even do search correctly. For instance, it goes back to the point you don't want to automate or even make something quote unquote more autonomous if you can't even have a good business process or a good process in place. It doesn't matter if that's car manufacturing or if it's software development. You don't want to automate something if it's not actually a process that's worth automating. And the same thing can be said in, like, for instance, search within chatbots. If we don't have those correct mechanisms in place, both from a software perspective in our organization, or even from a cultural perspective, you can try bringing a truly agentic application that has all the bells and whistles of everything we're seeing today to an organization that has never experienced generative AI. It will likely deal with low user adoption. And I've seen that at a couple customers that have tried to experiment with effectively an R&D team trying to push out something that's at the forefront when the end users themselves have never used these types of toolings and capabilities. So there does, beyond just a technical solution, also need to be cultural and an organization building up to that. Hopefully that kind of makes sense.
Yeah, that makes sense. I'm curious, like, is there maybe a tip or trick that you have that you've seen that would help someone, facilitate some of that adoption if they're in a position where maybe their culture's not there right now and they know the transformation will take a while? Is there something maybe short term that they could do to, prevent themselves from spinning out?
So when it comes to, I think it circles back to your AI use case scoping and road mapping, defining in your organization what all of the use cases are, and then not just mentioning we have, for instance, a dozen or 24 use cases, actually prioritize them by metrics such as tractability, feasibility, and at the end of the day, business value. Once you can go through that scoping exercise, then you can identify what's a quick, easy win that we can implement and what's more of a moonshot, what's something that we know the technology, but it's a little unknown the business value. Then you can have a roadmap of effectively building institutional trust by iterating out those quick, easy wins, and then working your way up to those longer, more moonshot initiatives. And ultimately, that I think from a strategy perspective is what every organization should look towards is how do we get quick, easy wins to show we're not just effectively trying to follow the hype, that this is not just a gimmick, and that ultimately we can work towards actually delivering true value. Since at the end of the day, time and delivering value is the true motivation that will hopefully bring cultural change, along with change management.
Yeah. Can I just two follow-up questions? When you're talking about agentic, can you just clarify exactly what you mean with throwing that word around?
Definitely, and it's right to be confused. They're used interchangeably, both the term workflows and flows and agentic applications.
Oh, okay.
But fundamentally, you can think about a workflow being effectively a deterministic flow or traditional conditionals, effectively, where if this event occurs, then this. It's effectively chained together these prompts that from these LM call saying, if this event occurs, then go down this path or this, depending on a flow within a graph effectively. For an
Right.
agent themselves, you're allowing them, and there's different agentic architectures you can use to implement of an agent, but an agent predominantly is composed, when people say the word agent, an agent is a construct effectively that is composed of a single prompt template, a reasoning engine typically of how it thinks through how to execute using reasoning or React or other frameworks. It has tools, effectively the ability to make either function calls or calls to APIs externally. That's where model context protocol and those other mechanisms come in. And then guardrails and security. So those are the key mechanisms about what composes an agent. And then you can have multiple agents that have those primitives built around and implementing. And that's where you can use tools and for frameworks like Bedrock agents that have
Okay.
memory, that have guardrails, that have prompts, that have access to tools that allow you to fully implement into a system. So I guess maybe to summarize, workflows are for deterministic paths, similar to how we've had RPA, or robotic process operation, in the past. Agentic applications where we define effectively an agent to perform a specific task. You have to achieve this high-level goal, or and then you are going to run in a cyclical loop until you do that. You have access to these tools. Think about it as an analyst, a junior analyst that you'd on board. You'd say, this is your guide of what you can do. This is the
Right.
functions you can perform, and then go ahead and prosper and run in this loop. There's different architectures of how to do this, and that's probably a deeper dive, but
Yeah.
at
Okay.
a very high level, just hopefully that makes
Yeah,
sense.
brilliant. We actually had a question from the audience. I'll bring that up, John. Sorry. Is our customers looking to build agentic cost optimization workforces for their environments? I don't know, John, if you've seen any of that in your customers.
Yeah, I think, Aaron, like you mentioned, we're seeing a lot of stuff, coming up on LinkedIn where, folks are sharing, MCPs they've built that are doing things like this, or different architectures, different models. And, it seems like every day there's something cool that someone's working on that they're able to share out. As well as, AWS, building, some of these capabilities into some of our platforms like QDeveloper, cost analysis functions, things like that. So I think answer is yes, fast moving space, something new every single day. Kind of going back.
Maybe just to add on to that, we do have like a tool that like a colleague on one of our teams released that is an MCP server that allows you to use Cost Explorer to effectively invoke specific tools. It's on GitHub and available. But I think, John, to your point, like these tools, I guess maybe to respond to the comment more directly, I think we're seeing individuals create effectively those agentic tools to allow you to interface with these common APIs so that agents have an easier mechanism to interface. But I don't think we've fully seen, for instance, your autonomous FinOps analyst just yet. I wouldn't be surprised if we see that in the future. But right now we need to work on those lower level primitives. And ultimately, if you don't have the right tag, even at a lower level, if you don't have the right tagging, or the right instance profiles to even monitor your tokens, your requests per minute, then it's a moot point. And I'll post the link right now to that.
Oh, perfect. John's got it. Let me drop this in. It's the repo that was mentioned. That is there. Oh, exciting to have a little nosy at that later, which is going to be cool. So, and in terms of people who are creating applications, how do you balance everything out? How do you take into consideration kind of cost as well as like scale and latency and stuff like that? What is the best mechanisms or tools people can use to make those decisions in a more accurate and beneficial way?
Yeah. Ultimately, it should start with the business, and really it should start with the scoping. And on the technical side, folks like myself and others, whether you're a data scientist or whether you're a machine learning engineer focusing on inference, or whether you're in FinOps, everyone has their own motivations and objectives. But ultimately, the product owner and the business needs to define really what is the budget and scope for this initiative. What is really the cost if we actually solve this, if we really knock this out of the park? We should really be able to measure and know what for every 1% increase in accuracy for this overall system, what actually net for the business. Is it worth, for instance, an additional 2 weeks of development time to get 5% more in accuracy? Because the cost of 5% is XYZ. So again, all of that is nothing that our technical builder teams necessarily have complete control over. That's more coming upstream from the business side. And if the business can further define those metrics upfront, then the individual teams that really in the RACI matrix are responsible, whether it's data science for accuracy, along with also machine learning engineering for speed and latency, and then ultimately cost controls from our FinOps and cost measures, then that helps inform really the key metrics of our model selection, whether we're using, for instance, a closed source model, or whether we're using an open source model, whether we're using a managed service solution like Bedrock, or whether we need to use a more of a or SageMaker or a self-managed open source on EC2 or EKS. But ultimately, those technical decisions need to be influenced by those upstream requirements, if that makes sense.
Yeah, making those decisions. Go on, John.
And I think maybe to double click on that one more click, I think ultimately what's super useful is trying to define like your cost per task ultimately when you're production. So if you define really these measures, then you can help influence what that actual cost figure would be. And when I say cost per task, it ultimately revolves around your model you select and the inference engine you're using. So when I say inference engine, that's what you load your model into and that you service. So that, for instance, for a managed service solution like Bedrock, that would be our cost per task would really be our on-demand model charge times the token count plus the knowledge base divided over like the total number of tasks. And in an inference as a service like SageMaker or self-managed EC2, that cost per task is similar. It's just that it's really the instance cost and our times our application uptime plus our knowledge base cost, if we're using knowledge base, over the total number of tasks. So similar constructs, but ultimately we can get these costs per tasks, and then we can use effectively some napkin math to figure out, well, how many users will be using this application, how over what time period, and then we can start getting figures of what that really means from a cost perspective and overlay that across really the entire business value of this use case to see really what the ROI is and what makes sense. And if it doesn't make sense, we can back into what parameters we need to change for that.
Yeah.
Aaron, sorry, Steph. Go ahead.
No, go. No, you finish.
I've got a question with that one. When we're talking about the cost per task, Aaron, how wide would you recommend customers go with that in terms of supporting costs for infrastructure, maybe getting data into this? Do you think that should be like one metric that they're looking at for, some of the AI specific infrastructure? Should it go wider than that? I'm just curious in your perspective with maybe what's worked for folks or some corner cases folks should think about.
I think it depends on the level of two things. One, again, if it centers first in that business value. For instance, it could be that cost per task is okay being very expensive because the value we're delivering to the business is something that's never been done before, and it's very, very high value. It also could be, though, for instance, let's take a simple example like a customer call center. Maybe paying someone, that hourly worker in the call center to help support them is cheaper and faster than, for instance, the cost of doing this with this system. So that's where those measures come into play in evaluation of both. In terms of, maybe the second metric in terms of instances, that really, the instance size really depends on the model you're loading, the size, whether that's a smaller model, a larger model for these open source models, and then ultimately where you need or how many different endpoints you would need to deploy in order to support the workload in the various regions available. So hopefully that makes sense and answers the question.
I have a really dumb question. I'm going to dumb it down for everyone. And I remind everyone, if you're watching, we're talking all about optimizing GenAI, asking the experts today. So please feel free to put any questions, comments in the chat. I see one I'm going to come to in a second. When it comes to using an EC2 to have a GenAI application, in terms of, and really, really simple, is it treating it like you would any kind of application? You load into the EC2 some kind of model. I realize how dumb I'm sounding. A model, and then you can interact with it like you would any kind of normal application. Is it as simple as that, or is there more kind of complexities with it?
I'd say at a very high level, and this is a deeper dive conversation, but at a very high level, there are what are known as serving engines. Serving engines are what we'll call VLLM or TGI from Hugging Face. These are open source serving platforms where you can load those. If you go to Hugging Face, you can find, for instance, Llama 4. Or you will download that model. That's effectively a file, a collection of what are known as safe tensor model weights that have been pre-trained. But once you have those weights, you need to serve them. so they can be serviceable through an API interface. And there's a whole world of machine learning engineering of serving that correctly and well, of continuous batching, etc. But at a very high level, you need to have a serving infrastructure layer. And that serving is the you need to have an instance that can power that serving engine. That serving engine itself is software, but effectively you load your models into and then can expose them as APIs that are effectively can be used by your downstream applications. There's a whole world in like which serving engine to choose and different parameters to optimize, but at a very high level, think about that EC2 instance being the infrastructure layer, and then there's a software layer effectively for loading the model, loading it up, and then effectively serving it as just you would any other service, like any other microservice effectively.
Okay, cool. All right, thank you for explaining that. Another audience question: how should organizations choose between custom engines, managed endpoints, and serverless options for inference? What is the best way to kind of get started with making these decisions?
Yeah, I'll say front and center again. You're probably going to hear me repeat myself, but it comes down. It comes down to because again, like as a data scientist, I'm going to say I want complete control and configurability, and maybe I want to do self-managed open source. But it depends. How much time do I have? Do I have enough time to, for instance, spin up in my own EC2 instance? And do I have enough time? Do I want to operate that? Again, self-managed open source, a lot more configurability, but then you have to operate and manage that outside of even development in production. So it comes down to ultimately, what are the requirements of the use case? Because each team will have their own motivations. Data science is going to want the most amount of control and configurability. That's going to be very different than the product owners. That's going to be contrary to the support team that has to manage this in production. So I think at a very high level, and I don't just want to repeat myself, but it really comes down to clear requirements up front that your team's defining to influence effectively everyone's goals, because they all have different motivations. I know that's not a direct answer.
No, so it's good.
Yeah.
No worries. All right, let's do a quick audience question, which is: are you tracking your GenAI costs? So, one for yes, two for no. I haven't. I started actually looking. I was on the phone with Adam the other day, and I was like, oh, do you pay for Playground? And I think we figured out that you do pay for Playground when it comes to Bedrock. I'm not really sure. We need to dive into it. But we saw like Bedrock costs coming up on my Cost Explorer. It was only a cent, so I wasn't blowing the bank. But I think that it's something like what we're going to dive into, not necessarily today, but we're going to try and do it in the next few weeks, is figuring out like what does that spend look like? I feel like I used to be able to rattle off a lot of spend information when it comes to GenAI. Okay, so most people are saying no. Okay.
I'll say maybe another thing too, maybe on that cost thing. Cost is one important, but accuracy is also, that's one of the funnels of our three-legged stool. It's really most organizations sometimes struggle with how do we test and evaluate for accuracy for our systems. Really, a critical component in doing that test and evaluation is having the ability to have a domain-specific data set. For instance, if your organization is implementing, let's just say, a chatbot to be simple, you should have as part of your release criteria, even whether you're data science, the product owner, or in FinOps, the ability to tell your team, well, do you guys have a domain-specific test evaluation data set, and what is your accuracy? So that you can actually know that what we're actually paying for is actually performing, so that you measure that. So in order to do that, you can work with your organization to generate these pairs. It's as simple as effectively saying, what are the questions users are going to ask in our application, and what is ground truth? You then run that through the system effectively that the development team has made. You will get output answers, and then you effectively look what is ground truth and what is the answer, and then you effectively give it a score between 0 and 1 based on that quality. And there's other ways we can do this, but 0 and 1. And then you can use that now to calculate accuracy. And with that, now you can definitively say, well, this system costs us X, Y, Z, and the accuracy is ABC. And now we can start, both from a data science perspective, working to further improve that. And then from a cost control perspective, have understanding into really what are we paying for?
Yeah, that's go on.
Well, one quick question, because I know we're about to kind of make our transition over, but as we're kind of talking about all of this, a big part of success, I think, is kind of managing expectations for the various stakeholders. I'm curious, if maybe you have like 1 or 2 tips on how to manage expectations around, this being maybe an iterative process, or what they should expect kind of upfront, or what the journey should look like. Is it something that's cut and dry, or should they expect this to be something that's going to unfold over a longer period of time?
Yes. Bottom line, I think the best way to do that is through in that use case scoping process with the executive sponsor effectively, and actually the end users who will be using this application. They need to be involved at different touch points throughout the development process and release stage. So for instance, you need to have a UA before doing a full release. If your user base is, let's say, 10,000 users, you should be doing targeted user acceptance testing, both closed and then open, over multiple periods, just as we would any other application. And they should be involved directly in the upstream use case scoping process, so that we actually know, for instance, assume everything works and it's perfect. Is this output even useful to you? And frankly, if those end users aren't in the room and don't say yes, and if you don't have an executive sponsor saying this is something I want to fund and would actually push to production, then why are we wasting everyone's time here? So that's ultimately the traditional product development cycle of having effectively your customers and customer pain points in the room, making sure we have a sponsor that's engaged, and keeping them engaged throughout the process will mean that that workload doesn't just die in the valley of death with pilots at the end, but actually can move to production.
Okay, 2 more quick questions before we finish up and bring on our next guest. Especially around cost, Aaron, what is your top recommendation for long-term efficiency? So you just dove into how to make sure that it's doing a good job in terms of accuracy, but what about long-term efficiency? Anything people should start to look at now to kind of be mindful of?
Yeah, definitely. I think long-term efficiency, again, circles back to kind of what we talked about earlier, making sure that we have our cost governance framework in place. Again, similar to every other application, but in GenAI, cost visibility. You need to have visibility into really ultimately the dollars you're spending per request per minute and tokens per minute for your individual workloads. You need to have cost governance to prevent overruns and set limits and guardrails. Cost levers and optimization, no matter your inference engine, your purchasing options, whether you're using on demand or provision throughput, the model selection you're using. Are you using a large model that's closed source or open source? And then what's your test and evaluation harness? How do we even know the system's useful? All three again are cost visibility, cost governance, and your levers and optimization. They all need to be engaged in those dimensions. Deeper talks we can have after, and there's definitely blogs available to dive deeper into each of those, but hopefully that makes sense at a high level.
Brilliant. And the very last thing I want to do is, we are all in the same department, and people from this channel know optics very, very well. But I wanted to also take the chance to highlight your awesome team. I've got so many cool people in it. So can you just take 2 minutes just to explain what your team, the name of them, and what you guys do day to day, so we can maybe like share this out after as well?
Definitely. So part of our team is that within AWS is helping some of our largest customers accelerate their journey into generative AI through training, model deployment, agents, and application development, by really helping teams, whether it's in the solutioning stage upstream in that scoping process, or through creating different solutions that we can open source to showcase really what is the art of the possible. And then ultimately helping teams tactically unblock issues at a more of a strategic lens or a tactical or operational lens. Our formal team is the AWS Customer Acceleration Specialist Solution Architect team, and we are comprised of a team of individuals that have experience in really doing AI for the past few decades. And then we're also working in tandem with our other colleagues that have traditional networking experience, security, cost governance, etc., as a true one team approach.
Brilliant. And if you have any more questions about that, please email costoptimization@amazon.com, and I can connect you with the right people. That is it. Thank you so much, Aaron. We're going to bring on Omri right now, and stick around just after this short transition, and we'll be right back. Votes in the chat. What do you think of our new transition? Our lovely kind of background producer, Mike, Jeff, made that for us. So anyway, but hi, Omri. Welcome to the show.
Hi, thanks for having me.
Yeah, thank you so much for doing this.
Yeah,
I'm excited to get into stuff. Yeah, there's some stuff we are going to transition over to a little bit more GPU focused is what we're going to do in your section, and also do a bit of a demo. So remember, everyone, you can still add any comments, questions in the chat for us to answer. But Omri, before we kick into it, do you want to give us your 1-minute origin story?
Sure. So I started my career in analytics consulting, so helping our customers with analytics types problems, solving those using my former company's analytics solution. And what it was a very large distributed database, and I found out I actually enjoyed engineering on the database more than the consulting part of it. So I kind of got into that. And then, of course, convolutional neural nets took off and kind of pivoted that into applying that to our customer problems. And through that, got introduced to more machine learning engineering, ended up working on our machine learning platform. And that team switched companies and built a second machine learning platform over there, MLOps platform. And yeah, joined about a year and a half ago, AWS doing open source machine learning engineering.
Brian, welcome. So let's get into the GPU side of stuff. Now, I feel like, again, another one of these things I keep hearing thrown around. Can you explain for us what GPU stands for and what is it?
Sure. So it's a graphical processing unit, and it's a hardware that you add to either a desktop or a server that's kind of made specifically for traditionally doing graphics processing. So that would be rendering video, video games, and whatnot. But ultimately, what it's very good at doing is computing things in parallel. And so, as we kind of created these very large networks that are basically very big matrix multiplication operations, these GPUs were repurposed to be able to do those computations. And so now this hardware, whether it's a GPU or an accelerator, like a AWS Neuron or whatnot, are able to do these very large math computations that we're finding are very helpful in today's day of AI and machine learning.
Okay,
Cool.
I didn't know that. That was the background.
And I was going to say, I think Aaron did a good job of like kind of teeing us up for this transition, because he was closing by talking about like from the cost lens for Gen AI and AI ML workloads. We want to kind of look at 3 different general areas around cost visibility, all the cost optimization levers, and then like the cost governance components. So I think that does a good job of kind of bringing us here around looking at like the GPUs as being the resource, kind of this one aspect of like a broader equation where it's a cost lever. We need to have visibility into how we're going through and using it, and then having some governance layers on top to make sure that we're getting the right stuff kind of out of it. And I'm curious, Omri, what you're kind of seeing out there in the field for how folks are sort of approaching that when it looks at taking advantage and best utilizing like GPU resources. What are some of the strategies that folks are kind of doing there?
Yeah, so I just want to kind of highlight that we also have sort of a very interesting quirk to this problem, is that even if you wanted and were able to kind of afford more GPUs, that they're not cheap. I think we probably all know that. They're also very scarce right now because everyone's competing for being able to use them, whether in the cloud or to purchase them for themselves. So even if you wanted to add more, it's not always possible. And so getting the most effective use of the ones you do have is kind of critical to being able to work with them and utilize them for your business better, rather than necessarily just trying to reduce the
More.
cost. Yeah.
Yeah.
Yeah. So sorry. So not quite an answer to your question, but just an added quirk to this whole problem.
Yeah, so setting the stage for it. So are you finding that folks are now, focused more on optimizing the utilization because, they're saying, hey, from a cost perspective, expense is high. We want to, get more focused on the utilization side of things. Or is that just a natural process that's happening with folks overall?
Yeah, I think it's kind of been coming for years, even before sort of the AI boom that we're in right now. For people specifically who are self-managing their infrastructure, whether it's using EKS or EC2 instances or running on-prem, just because if you're leveraging sort of the LLMs in Bedrock, there's not a whole lot you can do there from that perspective to be able to kind of get the level that you can of optimization with what you're doing self-hosting it. There's as Aaron said, you have more control over what you can do, and so when you use the self-hosted options, that's kind of what we'll get into, is some of the techniques where you can make the resources seem as if you have more of them by partitioning them or packing more workloads onto them.
Cool. And I have one question kind of before we get into, kind of optimizing the workload. Folks maybe are more familiar with looking at things like CPU utilization or memory utilization. How is GPU utilization different or the same?
Yeah, so with these very scarce resources, very expensive resources, and sort of resources that rely on being fed constant data, it's not enough to just look at how is the resource doing. Because if you look at the GPU in isolation and see that it's running at 10%, utilization, you don't really know why it's running at 10% utilization. That could be because maybe your job is misconfigured because it's not being able to drive more data to it. Or it could be something completely, seemingly unrelated, but actually related, like your network isn't fast enough if you're trying to load data into it, or you're using the wrong storage, or a whole host of other sort of issues. And so being able to understand that both from the data science machine learning side, as I'm a machine learning engineer, I want to know why my job isn't running as fast as I expected to, or a platform engineer, which is kind of what my background is wanting to know, we support all of these different users on our environment. They all want to run their job, but we don't have the resources to just keep buying GPUs or keep adding nodes to them because the nodes don't exist, or we're trying to be frugal. Why are we not able to drive more utilization on our environment? Is it something that they're doing maybe incorrectly, or is it something that we're doing incorrectly that we can improve? And so finding where that bottleneck is really important.
So I think a lot of people, when they think utilization and they think about, AWS, or they think about any kind of infrastructure and utilization, like their mind immediately goes to like a right sizing type of problem.
Yeah.
And, I think what we're kind of like unpacking here is like, hey, not quite the same when we're thinking about GPUs, want to kind of look at all these other different sort of components that are sort of feeding into it. And I know that can be the same for, a lot of compute use cases too, but I guess I'm curious, like, do you agree with that maybe when we're looking at utilization on the GPUs, this is maybe a little bit of a different problem set than like the common right sizing one that some folks maybe would immediately sort of think about as that pattern between, saving money with low utilization? We're looking at something maybe a little bit different, in this case.
Yeah, absolutely. And I think they both kind of play together as well, because especially since we have a lot of customers, I think, who are reserving, nodes, like buying capacity, because if you just want, a P5, you're probably not just going to get it. You kind of have to reserve these ahead of time, and probably multiples of these. And so we have a lot of customers who end up with some of these nodes, but then that's you have them, but then you want to put jobs on them, and so sometimes your jobs aren't really big enough to put on those nodes. Like, it'll work, but it won't fully utilize the GPU. And so then you think, well, am I going to underutilize it because I have it, or do I then get a smaller node and then pay more money? And so it's a lot of these very sort of multiple constraints and multiple variable type of questions we have to understand and ask ourselves how to best utilize and best optimize for our problem.
It's so similar to, I feel like, not so similar, but the concept of like, I've got this big one, I'm going to keep it because I don't want to lose it, and I need to just like try spending it. It's the same as what we hear a lot with customers who they overspend on a lot of their resources so that they use their budget. and then it means that next year they'll get the same budget. So there's this like awareness of like, I don't want to let it go. And so it's like that mindfulness of it, but I guess it boils down to making a good decision at the start. I do want to get onto your demo of your observability stuff. Before we do, I have a quick question from Travis, which is, are there AI/ML tasks that people default to running on GP2 that might be good candidate for CPUs?
Absolutely. I think a lot of the smaller models and a lot of maybe not the more traditional machine learning models work very well on CPUs. And I think we can share a link maybe after the show. We have some really cool benchmarks of taking some of these models and moving them off of a GPU and putting them on a CPU or even a Graviton instance where you're able to actually lower the cost of serving it by getting it off of the GPU.
That's awesome. And in a really simple term, is it because it doesn't actually require, like you said, that much of a processor to deal with the workload? Is that how
correct? And getting the data onto the GPU takes time. And so if you have these small models and you don't need to constantly load and offload them from the CPU to the GPU, you'll be able to serve them faster, assuming that the CPU can compute it faster or just as fast as the GPU.
Okay. All right. Let's bring up the demo that you wanted to talk through. We've got about just shy of 15 minutes. Do you want to set the scene on what this is and why people should be looking at their observability?
Sure. Yeah. So we have a demo, and it's an open source GitHub repository that that we created. I'm on the open source and emerging tech team, and so we wanted to give people the ability to very easily deploy an architecture that will give them all of the components they need for observability for their AI and ML workloads, and even beyond. It can be extended beyond that, but we sort of focused on at least the dashboarding components on what we see as the common AI and ML frameworks like Ray and VLLM. And so we have this open source GitHub repo that we can share.
Let me bring this up 1 second. There we go. Okay, go for it.
Okay, great. So if we'll share the link, and basically this is an open source deployment that you can take, and it will give you this architecture right here, and we can step through it really quickly. Basically, this is all running on Kubernetes. So this is at the node level. For the node level metrics, you're going to get to see things like your accelerator utilization. And then for the node itself, the CPU, the memory, the networking, and the storage. Those are the metrics. And then for the logging, you're going to get your job logs. So what's actually running on the AI and ML workload, as well as what's running on the node. So being able to correlate all of these things together in one location is going to give you a better, more holistic view of what the problem is that you might be having with your workload. And then if we scroll up, we also kind of aggregate what's going on in the Kubernetes environment as a whole. So we'll get some of the metrics of the environment, and we store that either in Prometheus or OpenSearch. And then we include Alert Manager to be able to send you alerts if something is not happening as expected. And so all that to say, let me zoom in a little bit here. I won't go through all of this, but this is to give you an idea of what the actual sort of challenge is with understanding your GPU utilization, and to show you how all of the components kind of play together to be able to affect the performance of that job. So this is all on the repository. You can watch it after the show. So we'll go into the inference dashboard. So this is Ray and VLLM, and we noticed a quirk this morning. We're not getting the logging output, but we'll fix that. We'll fix that for sure. Yeah, demo sort of issues. But you can see I have I'm sending it constant requests right now just to show that you can see how the utilization is changing over time and how those all correlate to all of the metrics. And so some of the really nice things you can do is you can actually see how if you highlight some point in time on one graph, it shows it to you on all the other graphs. So aggregating that
Ah,
with the logs gives you a really great way to drill down into what area of the job and at what point in time you had these issues. So we try and coordinate that all in one place, and you get a lot of metrics that that maybe you wouldn't have had otherwise. And so same thing for GPU. This one isn't running live. I ran this just before my segment, and it kind of finished off a little earlier here. So you can see the same thing here. We have a multi-GPU job. And you can see here we do have the logs, and you can see how, as you kind of look through the logs, you can see where how the performance was on the GPU, and then as well you get your network and your CPU and memory utilization. So all of this is to really allow you to identify a point in time of maybe there was an issue, and then try and see, well, was there something in the log that might indicate, oh, I was data loading at the time, and so everything is down because we're trying to push data to the GPU so that we can
mhm.
start training again. Or was there a different issue? Maybe my GPU utilization is hung and nothing is happening. That might be a point to for us to investigate. And so some of the things we're looking to add to this, and that's kind of why we integrated Alert Manager. We're, of course, following Aaron's talk about agents, going to look at adding maybe some AI ops to be able to identify some of these areas where we know what might have happened here, and we can maybe offer a fix for you, or try and recognize what the issue was and alert you and tell you, your GPU has been hung for 10 minutes. It doesn't look like your job's making any progress. Maybe you should cancel it so that you can free up the GPU and fix the issue you were having. So try and optimize and aid in that regard.
Yeah. It seems like a pretty cool tool. So guys, check that out. We put the link in the comments. Anything else you want to show on this?
I just want to say, this is all open source. This is a community project. So if people want to, we would love getting contributions on it. We would love to hear what you would like us to add to it. If you have any issues with it, please open them. We do really want this to be sort of a community project and not just us putting it out.
And
And,
Amri, well, I'm curious, kind of where you see customers at like the observability, maturity level with these workloads. I know that's a really, really wide range, but I'm kind of curious, are there maybe some pitfalls out there that you're already observing with customers where, hey, if they just have like, more granular observability, they would be able to catch some of these things, a little bit earlier on, or get better utilization out of the GPUs?
Absolutely. I think this was driven by sort of customer requests for these sort of things. So when I show this to customers, they really like how the logs and the metrics are in the same place, that they can hover over areas and see where the issue was and what was going on. So that correlation is very helpful for them to root cause things. I've heard from customers who didn't have a visualization to be able to get their logs. They were kind of having to dig them out of file systems. So this is a huge improvement there. And we want to hear what other people think is missing, and so that's why we want to open it up on GitHub and make it available to everyone.
Cool. I mean, I know one of the ones that really sticks out to me here is that we hear from a lot of customers that there's observability like somewhere in the environment, but they don't have access to it. And I
Yeah.
think what's cool about this, it democratizes it a little bit, makes it more accessible to folks, so that you can act
And
on.
that's a great point. One of the things I've heard is that people really like the Ray dashboards, but platform admins don't want to give them access to them because there's other things you can do on the Ray dashboard. So this actually aggregates everything you would see there and allows you to interact with it. And of course, Grafana has the concept of roles and that, and so you can create users and you can scope down what they're able to do, and so all of that is available in this package.
Brilliant.
Give a shout out here, Steph. I just dropped one link in that we should share out to, which is from a past talk that we did on pulling some of the cost data into Grafana. Because one of the other benefits that we have here is, got all this great utilization data. You can pull in, all your cost data kind of right alongside that too. So another one to check out as you dig into Omri's solution.
And one of the things the solution does include is it does start to collect cost data for you. We haven't exposed it on the UI yet, but that is absolutely something we're thinking is people want to know how much is this training job costing me? And of course, then again, to Aaron's point, is it delivering on what we actually expect it to do, right? If it's not accurate, it's not producing business value, well, maybe we need to rethink us running it.
Yeah, and we have a quick question, which is: would training custom model like Llama, sorry, accent, in EC2 with GPU and host the custom model in Bedrock for inference be good practice for heavy workload? Well,
again, it like everything in this field, it depends. If you want to reduce the burden of having to self-host your own model, to have to deal with the infrastructure, it depends on, do you have a platform team? Are they willing to support this? Do you want things like Bedrock gives you, like the ability to deal with auto scaling for your model? And so these are all trade-offs you kind of make with, or considerations you have when you select what target you want to deploy your model into.
Brilliant. And I want to quickly, there was something that we talked about before we get onto Richard's summary. We mentioned as like a last question in our kind of prep that when we were talking about Kubernetes specifically, that there were some ways that you could get more from your workloads when it comes to GPU. I think you said there were 3 of those. What were they?
Absolutely. And so I hate to rush this discussion because I feel like we certainly could talk about it for a while, but something we've seen our customers do and we sort of talk about is if you have these fixed resources, depending on your tolerance for errors, depending on your tolerance for resiliency, there are ways you can get more out of these static resources that you already have. So one of them is time slicing. So that's when you kind of share GPU amongst multiple users, because when you put something in Kubernetes and you give it a GPU, you can't share that GPU by default with anyone else. And so this is great for experimentation. So if you have like a Jupyter Hub environment where multiple users are using it, and they're okay with maybe not having the maximal performance from the GPU, but still getting all of the memory and potentially their job crashing if someone, OOMs are out of memory is the GPU, that's a great way to load more people onto that GPU that you wouldn't be able to otherwise. On the flip side, there's something called multi-instance GPU, where you're actually able to take a GPU and partition it. So in this case, we mentioned having that P5 instance where you have really big GPUs, but maybe aren't able to fully utilize them, but you have a lot of people that want to use those GPUs. That's a great way to partition them into smaller isolated GPUs. And there you do get that fault tolerance and that isolation. And then you're able to put more jobs on those GPUs.
And the last one in intent, is there more? Or is that it?
No, that's cool. There's one more we don't see as often, but yeah.
John.
I think those are the 2 main ones.
I think that was John, even though I told him. Okay, right, very quickly. Thank you so much, Ryan. I'm just going to bring up very quickly Richard's summary. If you don't know, Richard watches us and he's not AI, and he creates a summary for me to read out at the end. So you can always jump to the end of our videos to watch a highlights reel. So core methodology for GenAI cost optimization is the same, which is great for us to know. Cost visibility and governance are key for long-term efficiency. More GPUs are not always available, so utilize and prioritize and understand GPU utilization with AWS Labs open source. Definitely take care of and look into that. That has been it from us. Thank you so much for watching. Next week, we're going to be diving into a customer story, so make sure that you stick around, you join us next week, same time, and we will see you then. Thanks, everyone. Bye.